In this lesson, you will learn how to create a custom service interface that will be used to stop a robot. Remember that services are used when you need to perform tasks within a short period. Custom service interfaces are created in a similar way as custom message interfaces. So let's create a custom service interface. You open up your terminal and then you go to the workspace. From the workspace the to the package. Okay, so we are inside the package. So to create a custom message, a custom service interfaces, it's just going to be the same way we created the message file. So the first thing you want to do is to create a directory using mkdir, and then you name the directory SRV, which stands for service. So we're going to create a service, and then you go into the directory you just created, and from there you can now create your service file. So to create a service file, just use touch, and then we are going to call our service stop. Okay, so it's going to be capital S and then stop.srv. So a .srv extension means that the file is a service file. Press enter, and what we're going to do next now is to go to VS Code. But before that, let's go to the workspace and then open VS Code from there. All right, beautiful. So we can now go to the SRV file, which is here, and then we open stop.srv. So that is how you create a service file. Now we have the service file, but the variables inside it is empty. There's nothing inside yet, so we need to put in something inside. And the way we're going to do this is remember services have two parts or two phases. So the first part is the request, while the other part is the response. So in this case, we want to create a custom interface, a service interface, where you can use it to stop a robot. So immediately you call the service or you request for the service, it's going to get a response, and what it's going to do immediately you call it is to stop the robot. So to stop the robot, it's going to take the rear wheel and the front wheel of the robot, of the actuators in the robot, and then it's going to assign it a value of 0 meters per second. So what we want to do first is to have two request variable, and I'm going to call it int 16. So it's a 16-bit integer, and let's call it front wheel. So this front wheel stands for the actuator for the front wheel of the robot. And now another thing about services, which is the same way messages work, is that you can give it a default value. So you can initialize the variable to a certain value, which is what we're going to do here, just to show you that you can initialize. Remember, when we created a custom message, we only created the variables, we didn't initialize. But in this case, you can see that we can initialize the variable inside a service file, and the same way you can do inside a message file too. So I'm just going to call this 20, and then I'm going to put a comment which says front wheel velocity, or initial velocity, you can just put it that way, is 20 meters per second. Okay, so it's 20 meters per second. We're going to create another variable called int 16, and we're going to put it rear wheel. Now there's something that you need to know here. You might be wondering, well, int 16 and some other data types that we've been using, ROS has some specific data types that you can use. You cannot just use any type at all. So you have to follow the way ROS does its data type. So you can use double, You can use int, you can use a boolean, and some other data types like that. Okay, so we have 15, and I'm gonna call it okay, this is front wheel, not font. Front wheel. Okay, so I'm gonna say rear wheel initial velocity is 15 meters per second. So just like you do in messages, you can do in service files also. That means you can have a comment, and before the comment, you just start with a pound or hash sign, and then you whatever you type there is a comment. So we're just saying that this is the initial velocity. So we're calling this initial velocity just to say that we are actually giving it an initial value of 15. So you can set your values inside a service and a message file. All right, so but the difference between a message and a service interface is that messages don't have response. So in this case, we're going to put the response, and then remember, to put a response, you separate the request and the response with three hyphens. So just going to put bool and then the state of the robot. So oh sorry, stop robot. So stop robot, and then I'm gonna initialize this to false. So basically what I'm saying is that when we make a request, then we want the front wheel and the rear wheel to be set to 0. So when they are set to 0 meters per second, it means the robot is going to stop, and the response we want to get is this stop robot. So when we say stop robot, then it's going to be true. So when it's true, it means that we've actually called the stop robot service to stop the robot, and it's going to return true. But initially we're giving it a default value of false. All right, so when we are done with that, the next thing is to go to the CMake list. Remember, the CMake list is where you set up your configuration. So we're going to go to the CMake list, and we're going to come here. So because we already have the ROS IDO generate interfaces, the next thing is just to add the SRV. Remember, the SRV is under the service is under the SRV folder or directory, and then from that directory we are going to call the stop.srv. So this is how you name your service file. So it's the same way you name the message file. You start with a capital letter or a block letter for the first letter, and then the other one is going to be small letter. So if you have or if you are using like 2 words, let's say it's stop robot, we just do it this way, stop robot. So this is the naming convention that ROS follows. So stop robot, and then it's going to accept it that way. All right, so the next thing you want to do now is after adding that, I think that is everything. Yep, that is everything. Now we go to the package.xml file. We are not going to do anything here because we have already added the build depend, the ROS IDL default generators, the default runtime, and ROS IDL interface packages. Remember, you need these guys when you are creating your own custom interfaces, and the IDL stands for interface definition language. Okay, so we have everything set up already. The next thing we need to do is to compile or build. So we just run calcon build. Then let's see if there's any issue with our setup. Always trust calcon build. All right, so everything is fine. So the next thing we want to do is to source. So to source, remember, you can either do source and then install and set up the bash, but you can also use your stop like the dots, and then you use install, set up the bash. So those are the 2 ways you can source in for your ROS. So now we've sourced our workspace, we can then try to see if ROS can recognize the service file we just created. Now to test, remember you use your ROS2 and then interface. So after interface, we want to do show, and then you pass in the first thing is the name of the package, followed by, okay, that's total control, followed by SRV, and you can see automatically the tab completion helped us to finish this stuff. So when I click and enter, it's going to show in 16 front wheel and then rear wheel and stop robot. Okay, so it means that ROS interface is able to recognize the custom interface we just created. So what is going to happen now is that we're going to use this interface later. In the next two lessons, you will use this custom service to stop a robot. Actually, this is not a real robot. The examples are just to demonstrate the use of a custom service. So since ROS is a language agnostics, the service server we're going to write next will be written in C++, while the service client will be written in Python. So it means that you do not have to always have a C++ code, or maybe a server that is a C++ and your clients must also be C++. No, you can have a server in Python and you have a client in MATLAB. You can have it also in Java and other languages that is supported by ROS. So, but you don't have to use the same programming language, and this is something we're going to demonstrate in the next lesson, where we have the server in C++ and we have the client in Python, and yeah, they're still going to communicate to each other. Okay, see you next lesson.